we will be solving problem number 100, same tree problem, okay, of Leetcode. So we have been given two binary trees p and q, and we need to write a function to check if they are same. So let's see how do we define same. Two binary trees are considered the same if they are structurally identical and nodes have the same value. So here they are structurally identical and even the nodes have the same value. So 2 2 3 3 1 1. Okay, here first thing is that they are not even structurally identical. It's like mirror image, so it's not acceptable. Similarly, here they are structurally identical but the nodes are not of the same value. Okay, so we return false false, and here we say it's true because both of the conditions are met. Okay, now, so as we did yesterday, what we will be doing is like we'll be using the framework that we discussed yesterday to solve the problem. So to solve most of the like this approach can be used in most of the binary tree problems. Here what we will be doing is we'll be solving the problem in three parts. First of all, we will define the base conditions. Okay, then we will like call the function for left tree and the fx for right subtree. Okay, subtree, right subtree, and then we will try to join the solution for left and right tree. So let's see how can we do that. So first of all, so we have a tree and let's make a tree. So we have like some kind of tree here. Okay, 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 and what we have to do is first define the base conditions for our problem, and then we have to call the function for left tree and then function for right tree, and then we have to join the two conditions, the resultants of this, and to return the solution. Okay, like I discussed more about it yesterday, so maybe you can look at that problem. So let's see. First of all, we have to find if a particular node is same. Okay, so for that let's do, maybe suppose we have a function is valid. Okay, we'll define the function later. We'll say if this is a valid, like if they are same, is identical. Okay, maybe something like that, and we'll say p comma q, will pass this. Okay, then we will say we'll call this function. Okay, this is our step one, this was our step one, define the base conditions. So like if the root itself is not valid, we will say return false. Okay, so that is our base condition. Okay, we will say return false. But suppose if it is valid, okay, the root is valid, using this simple formula, what we will do, we will say call this function for the left tree. Okay, sorry, we will say do this for the left tree. Okay, here what we want to do, we will say left tree. Here we have two nodes, right? We have to check if this and this both are valid, so we'll pass both of this. Okay, we will say p dot left comma q dot left. Okay, what we are doing, we are passing both the, means this is our left problem, left sub problem, and this is our right sub. So we are passing left of both the trees as a sub problem. Okay, so we are calling this function with the left side. Similarly, what we can do, we will say is same tree, and we will say p dot right comma q dot right. Okay, and we'll have to join this. Okay, so if this is correct and this is valid, both are valid, then we will say okay, it's fine, return true. So let's see. So for that we'll have to store the values. Okay, we will say boolean left, here we'll say boolean right. Okay, if left and right both are true, return true, else return false. Okay, now but we have still not defined the is valid. Okay, so validity for two nodes, this will check the validity of nodes. Okay, as we are doing here, like this and this. So how do we do that? We'll say if sorry, public is valid. How do we check the validity of this? We'll say same to same command C say if p equal to null and q equal to null, both are null, both are equal, so we will say return true, right? Similarly, if p dot val, if p dot val p equal to null or q equal to null, return false. It means that here we established that both are not null. Okay, like if both are not null, neither this is null nor this is null, then return true. I mean, if both are null, we will say yes, both are equal, return true. But if this is not passed, then we'll reach here. Okay, and we'll check if either of them are null. If either of them are null, it means that one of them is not null, right? Because in that case, like this would have been true. If both were null, this would have been true, but we are checking if one of them is null. If one of them is null, it means the other one is not null, so we'll say return false, because those are not valid trees. Those are not equivalent trees then. So now we can say if, okay, so this is checked. So now can we say yes? Now we have one more condition, right? If p dot val equal to q dot val, will say return true. Okay, else return false. Okay, so here we have that, like both the values should be same, right? P and q's, both values should be same. If those are equal, return true, else return false. So now let's see. Run. If left, okay, here should be left and here should be right. Now let's see. If both are true, return true, else return false. Now we have a null pointer exception, right? It's a very interesting thing. So reason is that suppose if it returned false, we return false. Okay, but what if those both were null and we got a true? So in that case we are getting a null pointer exception because of this. Okay, so we can write one more condition here that will be added to our base condition, that if p dot left or p equal to null and q equal to null, return true. Or even we don't need this. Okay, because since we know that this test case has passed, because of which we are here, right? This condition has passed, like this is a valid tree, and if one is null, it means that both are null. So we need not like write both are null, but For sake of clarity we can write, but let's let it be like that, and let's see. Okay, now let's submit. And yes, it has successfully submitted. Thank you.